Hey everybody, this is Mr. C, and this is Ready, Set, Go for Unit 1, Lesson 3. For question 1 here, we are being asked to describe, well, not describe, but determine what type of transformation is occurring from this original image up at the top left and for each subsequent picture for A, B, C, and D. For A here, this is a, looks like a rotation going 90 degrees counterclockwise. If we see we're turning it, the original image 90 degrees counterclockwise, we'll end up with that image. For B, the dot here is going to end up in the right corner, so that is going to be another rotation, another 90-degree rotation, except it'll be clockwise. With the rotation, so 90-degree clockwise rotation. For C, this is going to be a reflection, and we could even specify it would be over a vertical line reflection, so a reflection over something like that. And then for D, we're going to have to do a combination. And there's several ways you could do it. You could do a reflection first or a rotation first. I'm going to do a rotation first, 90-degree clockwise rotation, and then a reflection over a horizontal line. Okay, so we're going to do a 90-degree rotation clockwise, followed by a reflection over a horizontal line. And that is question number 1. Question 2, we have this triangle here as our original image. And for A, looks like we have a reflection. We're going to need to rotate and reflect. So we're going to rotate. And then reflect. For B, looks like we can just do a 90-degree rotation. For C, looks like we can do a reflection. And for D, we're going to have to do two things here. We're going to have to rotate and then reflect. And that takes us to our set. On each of the coordinate grids, there is a labeled point and a line. Use the line as a line reflection to reflect the given point, and label the image appropriately. Okay. So here's our pre-image at A, and recall that our reflection line, our point and our pre-image and our image need to be perpendicular to that line of reflection. So our line has a slope of 3/1. So our reflection line needs to have a slope of -1/3. So we're going to go down 1/3. Okay. And that one step takes us to the line of reflection. So we're going to do another down 1/3, and that is where A prime is going to be. And we can see that that's going to be perpendicular to our line of reflection. All right. Reflecting point B over the line, or line K. So checking out our slope for this one, we need a couple of points on our line to figure out what that slope is going to be. So we can just do those two right there, and we can see that this is going to have a slope of -1/2. So to reflect this, we're going to have a positive up 2/1, and then another up 2/1, and that is where B prime is going to be located at. For question 5, slightly trickier, but we can still do. We have a point that's not on a exact coordinate, but we can still make this happen. So our slope is going up 2/1, so our new slope is going to have a 1/2 or -1/2, I should say. So if we go down down 1/2, and that's going to be off of our point. So we can't exactly do this exactly. So we're going to have to figure this out another way. Okay. So what I'm going to do instead is I am going to do approximately a 90 degree, using my ruler here, line up 90 degrees and then I'm going to use the distance, kind of using my ruler as a measuring tool. I'm going to go that same distance way on the other side. So it's going to be slightly off Won't get an exact coordinate, but we can get pretty close to where C prime is going to be. All right, and then 6, I think we're going to have the same issue. So we're going to have to do the same trick with our ruler. We're going to have to line it up so it's perpendicular to our line of reflection. And then I'm going to go that same distance. So this is like 2 plus 3. 2 right there to that mark. And that's where D prime is going to end up. Okay. For 7 and 8, for each pair, P and P prime, draw in the line of reflection needed to reflect P onto P prime. So for these ones, we do have nice clean points. So we're going to be able to draw an exact line of reflection and get that equation. So on our P to P prime, you can see here our slope is going to be going up to over 4, and the halfway point between P and P prime is right there. That's our midpoint, and our slope of that is up 1 over 2, so that slope is 1/2. Our perpendicular slope for our line of reflection is going to be negative 2 over 1. So from this midpoint, I'm going to go down 2 over 1, down 2 over 1, and backtrack the other way. Okay. All right, so this equation, slope is going to be negative 2x. And there's a couple things here. I could just write a point slope form of this equation, but I think I can work out where my y-intercept is going to be. So here's 5, and then up 2 from that point, that's going to be a y-intercept of 7. So there's my equation. Okay, and then for 8, same thing. Let's draw our corresponding points line and figure out where our midpoint is going to be. So it's going to be right here at the origin. The slope of this line is going to be down 2 over 5, so two-fifths as our red line slope here. So our coordinate slope between P and P prime. Our perpendicular line for our line of reflection, we're going to flip that and change this line, so it's going to be going up 5 over 2, and that's going to be going through our midpoint here. So we're going to go up 5 over 2. There's 1 point, and then I can backtrack that the other direction by going left 2, down 5. So there's 3 points that I can sketch my line of reflection through. Okay. There's our reflection line. And the equation of that, well, we have our slope, y equals 5/2 x, and then it goes through the origin, so our y-intercept is 0, so that's just going to be our equation right there, y equals 5/2 x. Question 9, rotate clockwise around the point -3, -4, so that's point A there. Okay. And 90-degree clockwise rotation, I'm going to take a little radius here and I'm going to rotate that guy 90 degrees clockwise, like so. And that's going to tell me that point B prime is going to be right there. And I can do the same thing for C. C is going to be an additional 3 units this way. And there is C prime. Now I can kind of see the bottom of my arrow. And from here, I can really just kind of, knowing that my shape is rigid, D is going to be 4 units above C. So there's D prime. F is going to be 1 unit to the right of that. And we can build the rest of our arrow. E is going to be 4 units above B. G is going to go to the left there. And then H is going to be 2 units and halfway between G and F, so right there. And there is our rotated 90-degree arrow. For 10, this weird looking stick figure guy, we're going to rotate 180 degrees about the point 1, -2, so that's again point A. I'm going to start with the points that are on, like crossing grid points here. So we'll start with maybe this closest point. Now when I rotate 180 degrees, a little trick here to do this is that it's going to be on the same line, okay, because 180 degrees is half of a circle, so it'll be on this same line here. And from A, that's a down 1/4, so if I repeat that down 1/4, I'm going to find where my point, this point right here, is going to end up. So if I go left 2, 4, and up 1, I can find that first point right here. Okay. And then I'm going to build this like triangle head here. So this is we'll do the top part first. So from this top part right here, if I go down 3 and over 5, that will give me the top of that triangle there. So up 3 over 5. There's the peak of my triangle. And the eye right here is going to be right below that. And I can start. Start drawing the rest of this. The other point right here, that's going to be, that's 1, 2, 3 units away. So if I go from this point, this is this point here, so that point is 3 to the right, so I can build that 3 this way. I'm going to use my rigid. Okay, so now I got the head of my little stick figure here. And this point where he attaches to the where the neck is, that's going to be about 1.5 points this way. So 1.5, there is where the neck attaches. And then there's this other point. Okay, and then that got the full top triangle here, okay? All right, now we need to get this middle triangle for the body. So I'm going to use some more rotations of these individual points. So from A, this goes out 4, up 3. So if I do the other way around, out 4, up 3. That's where that point moves, 180 degrees. And then spaced from that, there's going to be 1, 2, 3. There's the triangle of the body. Okay. The legs attach at these 2 points. And so we'll use maybe orange for this point right here. So from here, goes out 3, up 2, 4, 5. So here will be out 3, down 1, 2, 3, 4, 5. That is the bottom foot there. And to get the end of that foot, that's just going to go in horizontally about 1.5 units. So I can draw one leg there. And I can kind of just visually get the rest of that. Oops. And there's our drawing, flipped around 180 degrees around point A. Okay. For the go, 11, 12, and 13, write the slope of a line that is parallel. So I don't need the equation, I just need to look at the slopes here, okay? So parallel means same slope. So for 11, slope is going to be the same. It's going to be -1 or -3. For 12, slope is going to be 7. And for 13, I got to do a little bit of algebra on this guy because I can't quite read what the slope is. We're in standard form here. I need to get this in point slope form. So I got to solve for y here. So the first thing I'm going to do is I'm going to subtract 3x from both sides. So that now I have -2y equals -3x plus 8. Then I'm going to divide everything by -2 to get y by itself. So my equation becomes y equals, negative and negative cancel each other out. So we have 3, positive 3/2 x, and then this will be -4. But I'm only interested really in the slope here. So that's the slope. So slope of a parallel line would also be 3/2. For each linear equation, write the slope of a line that is perpendicular. So same thing, we're going to be looking at the slope. Except that for perpendicular, that's opposite reciprocal. So we need to flip it and change the sign. So the slope for number 14 of a perpendicular line would be positive 7/2. For 15, we're going to flip it and change the sign. So that would be -5/1 or just -5. Number 16, again, we need to do some algebra before we can figure out what our slope is because we don't have a y by itself. So we're going to subtract 3x from both sides first. So then we have 5y equals -3x minus 15. And we're going to divide everything by 5. So that our equation is now y equals -3/5 minus 3. And now we can see where our slope is. Our original line is -3/5, so perpendicular line, we're going to flip that. It'll be positive 5/3. And then our last questions here. Find the slope between each pair of points, and then use Pythagorean theorem to find the distance between each pair of points. You may use the graph to help. Okay, so let's draw some axes on this first one. And our points are going to be 1, 1, so right there, and -2, -3, right there. Okay. So there's our line. So the slope of this line is going to be positive. So we're going up. 1, 2, 3, 4. And we're going over 3. So there's our slope. Up 4 over 3. For the distance, our slope kind of helps us. We can do Pythagorean theorem because we have a little right triangle here. There's our right triangle. We just need to find the hypotenuse of that right triangle. So using Pythagorean theorem, a squared plus b squared equals c squared. We'll substitute in the a and the b. Four squared is 16. 3 squared is 9. Add those together and we get 25 equals c squared. Take the square root. And we get c is equal to 5. So the distance is going to be 5. Okay. This one I'm going to draw my axes maybe a little bit further up here because I notice some negative numbers here. So we're going to be negative in the y's quite a bit. Yeah, actually it'll probably be okay just somewhere in the middle. I think we got enough graph here for these. So our first one, negative 7, 5. So we go 1, 2, 3, 4, 5, 6, 7. Up 5. There's 1 point. And for our second point, negative 2, negative 7. Negative 2, 2, 4, 5, 6, 7. Okay, I'm going to use my ruler to connect these dots because they're kind of far apart here. Okay, this has a negative slope, so we are going down 1, 2, 3, 4. And then, no, sorry, down 5. And then down another 7, so that's going to be a length of 12. And then we're going over 1, 2, 3, 4, 5. So our slope is negative 12 over 5. Again, we're going to use Pythagorean theorem to find our distance. We'll just plug in our values into Pythagorean theorem. So 12 squared plus 5 squared equals c squared. 12 squared is 144. 5 squared is 25. Add those together, we're going to get 169. Take the square root, both sides, and the square root of 169 is exactly 13. So that is our distance. And that's the end of this Ready, Set, Go video.